it's Fabric. It's a larger portion. It's a larger application, so there will be quite a bit of number of series. Hence the reason why I named this one Part 1. And here I'm only focusing on data engineering. As you know, the Fabric has different roles based on the users. So with that being said, I'm just going to do a quick intro of what Fabric is, and then we can proceed from there. All right, so Fabric, it's an all-in-one analytic solution, and usually this is really based off enterprises, covering everything from data movement to data science to analytics and business intelligence. And we will see all that come together and why we want to consider Fabric. So this is the last definition that I will ever do as we go through this series. So catch on that. Then from definition perspective, now from data engineering side, it does enable us to, for the users to be able to design, build, maintain infrastructures and systems that collect and store data. So you're taking Fabric now from data engineering perspective, and you're able to design and then build the infrastructures, then use those infrastructures to be able to collect data and then store that data, analyze it, and mostly on a large volume perspective. And then it does offer us a very comprehensive suite of services, which include data lake, data engineering, data integration, all in one place. And we'll see that in just a few. Now, if you are an data engineer in Fabric perspective, these are things that you can actually be able to do. You can be able to create and maintain lake houses. Then you're able to build pipelines, which is now the data movement process. Then you're able to use Spark, which is a language for us to be able to do data definition, batch, and streaming. And then you can be able to use notebooks. So notebooks is like a canvas. It's just like your notepad where we can be able to write code, but then you're able to share it. And we'll talk about that in details a little bit. Now, what you see the image at the very bottom, that's the features that come in with a data engineering role or data engineering piece of Fabric. So you have your lakehouse, you have your notebooks, then environment, which that's a preview. And then you have your Spark jobs that allows you to schedule and stream jobs. Then you have your data pipeline, which is your process of moving data back and forth. And then you can be able to import notebooks that have been written by somebody else. Now from Lakehouse perspective, and we'll look at these features, all these features as we go. We will not be able to finish all of them today because it's quite a bit. So today in this one, I'm going to focus only on Lakehouse. Then the next series, we are going to do the notebook, the Spark jobs, and moving forward. And then we start looking at the other rows. Now from Lakehouse perspective, this one is a data architecture that allows you to store data and manage it. Now the joy of it is that you can be able to do structured and unstructured data all in one stop. And then you have a ability to do SQL queries if you're SQL proficient. So this one makes life easier if you're using, if you're a user of SQL. But also, as I mentioned, you can be able to do Spark. That's the other one that you can be able to use in order for you to be able to interact with Lakehouse. And we'll see that in the demo in just a few. And then from Spark job definition, this allows you to be able to create and or define jobs that you can be able to execute, and those jobs allows you to be able to do data input, data output. We're able to do transformation, configurations, and then configuration settings so that you can be able to, like for instance, to schedule it so that it can run on a consistent basis. But this does allow you the Spark job definition, the piece of the Spark piece in data in Fabric allows you to be able to execute jobs. That's the main role. And then it does allow users to be able to do batch and streaming. So batch is where you do data in increment phases, where we can say, okay, give me data for every, like most of the organizations will do load data once a night or once a day, which is usually at night. That's what we call batch processing. And then we have what we call streaming jobs, which is where now I'm continuously getting this data. Think of it like from a banking perspective. where you want to make sure that there is no fraud. So you want to monitor that data as it comes, and when somebody uses their M-Pesa, we want to be aware, or we want to have that continuous streaming so that we can catch the bad guys if there was any manipulation or fraud happening. So that's the other job that we do have with Spark job definitions. And then what that does is that it spins a Spark cluster, and then it applies the transformation logic to the data, so that now your data, as the data gets to the data to your lakehouse, it has already been transformed. And transformation is something that we've talked in length in the last few weeks. Then from notebook perspective, as I was mentioning, this one is more of a code writing tool where we can be able to share, and actually you can even be able to do visualizations in notebooks, depending on which notebook you're using, and then depending on what libraries you call. And this is something that we will look down the road, how you can actually be able to interact with notebooks. Now, from code execution perspective, as I mentioned, you can do either Python or R. R is a language. And we can, as I mentioned, we can have that debate with whoever which one is greater, but Python has much more reach because like now what Marvin has used R for is not for data analytics. He's using it for web application. So that's the other piece, that R becomes much more widely used than R. But when you're doing R, you're really focusing on data analytics, and it's really a perspective of data. And then you can also be able to do Scala. And Scala was introduced with what used to be Hive, or what used to be, actually this now has become really obsolete and I've forgotten the name. When the big data came into picture, it's Hadoop. So that's where Scala came from. So we used to have Hadoop where we had the ability to spin multiple, we call them slave servers, where you could be able to spin a machine as quickly as possible. And that's where that language was coming from. So now I can't really focus on that because I don't want to peel another onion. But that's where you have Scala, which is still very widely used. But you're going to find it mostly with people that did Hadoop. Then, of course, you can be able to use it for data ingestion, for preparation, for analysis, and other related tasks, as long as you're calling the right libraries for it. Then from data pipeline perspective, you have this is a series of steps where you're able to collect data and then transform it. I think this is also something that we've talked about widely. It's almost similar to what I showed last week when Dominic was showing the SSIS. So this is the online version of it. So it does allow us to be able to do the data transformation. And then a cloud, it's pretty cloud. It's not something that you do on-prem. So then ETL. So in that scenario, now from data pipeline perspective, it's our ETL in Fabric. And when you're doing Fabric, you have 3 different core features that you can be able to use, which is either the data pipeline, which is the copy activity. Then you have your data flow Gen 2, which is also a process of moving data from one side to the next, or you can be able to use Spark as well for you to be able to move data. Now, the key thing with Fabric is that all these features here, they are all doing the same thing. But there's key differences, especially when you're talking to a customer, to be able to understand which one you can be able to use when. And with that, I've kind of prepared a table here that does allow us to be able to, see where we can use one over the other. So from use case perspective, the pipeline versus the data flow versus the Spark. So when you're using data lake, when you're putting your data into a data lake, or when you're moving your data to a data warehouse, then the pipeline copy activity is what you want to use. If you're doing your data wrangling, data profiling, then Gen 2, data flow Gen 2, that's where you are going to mostly see that. And these are some of the questions that do come in there in your certification exam if you're taking that. So these are some of those questions that they would ask, give you a scenario, and then ask which copy activity or decision would you use. So I'm not going to go line by line, but I'm going to focus on some of them. Like for instance, here you have your primary development skill set, which does do the ETL, the SQL, the JSON, and then you can do the same thing here with the Gen 2, which is the ETL, but here you're using the M language. M language is very common in Power BI. That's where we usually use it, especially in your Power Query, sorry. So when you're using Power Query, that's where we apply the M language. And then, of course, you can still be able to do SQL. And similar situation with Spark. We can be able to do Scala, Python, Spark. So it kind of gives us that ability here, where I would say that as we go through this progression here, that you'll notice Python is very, very powerful, that we can actually, we would honestly want to be leaning in that direction. And then from code perspective, when you're using pipeline, it's a no-code process or low-code. But when you're doing the Spark, then of course you have to write your scripts so that you can be able to get that copy activity to run. Then from volume perspective, these are the key pieces that the customers would want to know. It's low to high, and then all of them are low to high. And then the development interface, this is a wizard. Where it's a click, 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 and then Power Query. As I mentioned, that's what we do from M perspective. So Dataflows, we are also using Power Query. And then this one is going to use notebooks. Goes a little bit further. Now from sources perspective, this is now where you make the decision, really. Because it does define how many connections you can be able to bring into your data set. So from pipeline perspective, we have 30 plus, 150 plus, and then hundreds of Spark libraries. So the more the data source, the more you want to look at a higher version of it, which is mostly Spark. But when you're having, I think also 30 plus data connectors, it's data from sources perspective, I think still 30 plus. These are the very common ones where you have your SQL, you have your Hive, you have your AWS, you have your text, you have your things like, for instance, Excel and such. So those are the connectors that are allowing us to be able to get to the data. And then from destination connectors, so about 18. So then from Dataflow perspective, we can be able to dump our data into Lakehouse, Azure. So you can see that's really specific to Microsoft here, versus what you can be able to do with pipeline here, where you can be able to push data to a non-Microsoft environment. So like, for instance, AWS, GCP and such. And then Spark is, it's open source, so you're going to have, based on the libraries that you're using, you have access to much more data points or data sets or data destinations that you can be able to write your data to. And then from transformation, you can see that there. I'm not going to dwell much on that. So that's from the copy activity. Now, once you copy the data, or once you decide where your data is going to come from and where your destination, where your data is going to come from, and then the destination, then the next key piece that you want to make decision of is the storage. So that storage requires us to either make a decision whether we want to do a data warehouse, or whether we want to do a lakehouse, whether we want to do a data mart, or we want to do the KQL, which is the event house. So key query language, that's what that is. So those are the storage, the 4 storages that we can be able to use from Fabric perspective, and each storage has its own use case as well. So you want to also be familiar with the use case so that you can be able to make the best decision on which one to use. Now, I am going to quickly go through this as well, but you can see key ones here being the write operation. So this one here. What you want to use. So you can see that's important there, so that if somebody is proficient, I can't speak this morning for some reason. If somebody is proficient on data warehouse, T-SQL is the way to go. If it's Lakehouse, you can be able to still do your Spark, Scala, R, and such. So that's my write operations. And then whether I can be able to do multiple table transactions here in data warehouse, I can. And all this become roles. So this becomes a role in Fabric. This becomes a role, which is the data engineering. And those are different roles that we're going to look at while we progress through this. And then from security perspective, which is always a key feature that the customers want to know, if we want to do row level security, then the KQL will be the way to go. But I can be able to still do the row level and table level security if I go the Lakehouse route. And then of course, I haven't tested that on data warehouse, so I don't know about that yet. So that's something that we will look into as we go. And then primary developer persona, that's another piece there. So here you have your data warehouse developer, you have your data engineer and the data scientist, and then this is the citizen developer. So this here, this is why we want to be cognizant of Fabric, because now everybody can be able to create their own dashboards. So dwelling on Power BI as the expertise is no longer, it's actually going to become obsolete here pretty soon, because you can really give your entry-level person data and tell them to go create a dashboard, and they will easily be able to do it. So that's the other piece there that we want to be aware. Then from the access perspective, we have the ability to create shortcuts. So I do have one on my machine. I'll show you guys in just a moment. Then we can be able to, we can do shortcuts on data warehouse as well as data lakes, or as well as lake houses. But we can be able to do those with Power BI data mats, but we can do that with KQL. So I'm not again going to dwell fully on this. So this is going to be available to us, so you can be able to see here. Now, let me look at one of the scenarios here that we might encounter. So the person that's not here this morning, Eric, let's imagine that he's a data engineer and needs to store data, and model several terabytes of data in Fabric. So the team that we have here, we have expertise in PySpark, that's a library that you get with your Python. And then they do also have T-SQL skills, which is the transact SQL skills. Most of the team runs T-SQL queries on the customer side, but they don't really write. They just do. They don't do therefore don't need to write the insert, update, and delete scripts. They are not writing those. So the remaining of our developers on this side, we are comfortable with notebooks because we can be able to share those. And then we want to store our data in Delta, which is the changes that are Delta that are able to interact with in similar SQL syntax. So what would we recommend? What would Eric recommend to store the data in? So based on what we've seen so far, any takers?
The Lakehouse.
Why?
Because we're saying we're able to query across most items, and most of that we're doing with the Lakehouse and with the data warehouse, but more so with the Lakehouse.
Correct. Yeah. So that's what we would use. So these are some of the scenario questions that you would get in certification test. They give you a scenario and then ask what we would recommend. So those are the data stores. Now moving a little bit further, as I mentioned, I want us to focus on Lakehouse today, despite the fact that there's Fabric, there's quite a bit. So I'm gonna try to get you guys from 0 to 100, but my 100 wasn't really 100. So I'm going to actually, for this scenario here, I'm gonna get you guys from 0 to maybe about 70, since I had a job failure that happened during my data processing process. So I'm still trying to figure out why my processing for this Lakehouse is failing. So from Lakehouse perspective, what we've done originally, or what we've done over time, is we have built data warehouses since 60s, data warehouses have been there. And we used to call those traditional data warehouses. Then in the last about 5-8 years, we've developed, or the industry has changed to what we call modern data warehouse. The modern data warehouse is where now I'm able to transform data in flight. I'm able to ingest machine learning to the data. I'm able to move my data to the cloud. So or my data storage to the cloud. That's where the modern data warehouse comes in picture. Then the data warehouse, I think this is something that I've also presented to you, to the team here in the last couple weeks. We are able to only store structured data. So we have the ability to store data in tables, and that's what we call structured data. So I can go and say that my data is on row 5, column 8. So that's the structured data. Then we, in the last maybe about, I can say maybe also about 8-10 years, maybe 10 years, there was the introduction of what we used to call a data lake. In the data lake, the concept behind data lake was for us to be able to gather all data that we can from anywhere and everywhere and store it in our environment in hope that we are going to use it at some point. So we ended up with massive amount of data. So this is the whole coined term of big data. But what organizations have found in the last 3-4 years is that the data that's in the data lake is actually pretty useless, because I get to store that data. I'm pulling it from all areas, but I don't get to use, I only get to use about 20 to 30% of it. With that, now we've shifted from having a data lake and only bringing data that matters to us. That's why now we have the lake house. So that's the progression of how lake house came about. So, and the lake house allows us now to, we get away from trying to store all type of data, and we allow the modern data warehouse to store the structured data. Then from a lake house perspective, now I bring the data that I need to make sure that my organization or my business is doing what it's expected, and I store now that data in my lake house. Because the modern data warehouse does not do unstructured or semi-structured data, that's now we're going to store that in the lake house. So from big data perspective, the semi-structured data, that's where you have, like, for instance, the XML. I can be able to find a node from one end to the next. So I can tell that this is a block of data here. That's solid block of data. But it's not really structured. I can't tell you from node to node that I'm going to have consistent that line 5 is always going to be X. So that's my semi-structured. And then you have your unstructured data, which is just like somebody decided to write a notepad, and then they go type, or if you think of it like logs, and I'm trying to kind of make it make sense. Logs, like, for instance, from your computer, it crashed and you're trying to figure out, okay, it has given me all this type of logs. So that's a log file there. So most of the machines that we do interact with today, from your phone to your windmills, they all generate this data. This is the unstructured data. So because that data cannot fit in our traditional data warehouse or our modern data warehouse without a lot of transformation, we store that in the lakehouse. So now you have that. You have the lakehouse, and then you have your modern data warehouse. So what organizations have done is that we end up with both, because we still want to store data that matter to us, that's semi-structured and unstructured, but we don't want to just store it. We want to use to store data that we can actually make decisions out of. So they run both of them in parallel, and what you end up with is data silos, and you can end up with data duplication because sometimes the data that's stored in one can be in the other. And then the footprint, which is now your total cost of ownership, becomes much larger. So what Fabric has done is has unified them together. So you have your data warehouse, you have your lakehouse, So you can have the option of creating one or the other, or in scenarios where you do both, you can actually be able to build both. So you can implement both together so that you can utilize, and then the process of getting the data out for both of them so that your users or your consumers can be able to use it becomes much easier. So that's where Fabric comes into picture. So Fabric does allow you to create both the data warehouse and data lakes, and then not data lakes, but lake houses, and then be able to store that data in a way that we can actually be able to use it. Any questions so far? Okay. So the next piece that we're going to do here is now I'm actually going to work on implementing a process that will get us into Fabric. And then from Fabric, then we'll start looking at the data. So when you're working with Fabric, what we use is called a Mendelian structure. And the Mendelian structure is the new way of looking at the data. So medallion is just like you go to the Olympics, and from the Olympics perspective, you are given a medal based on how you performed. So that's the same system that now we're utilizing when we store data into Fabric. So you have your data layers, and the data layers are denotes the quality of the data. So you have, like, for instance, you have your bronze, which is your raw data, and then you have your silver. This is data that's validated, that it's clean and it's good to use. And then you have your enriched data, which is your gold standard, and at that point, this is data that can be trusted within your organization. If you've dealt with Power BI for a while, you'll notice that we usually have promoted data or certified data. So that's the same medallion architecture that we use for that. Now, all this data, before you can get it to gold standard, you have to go through what we call an acid test. So acid test, it has been there for ages and ages when we store data in data warehouse, which means that we have data atomicity, we have data consistency, we have data isolation, and then from durability perspective is also ensured. So that's what this architecture looks at here. Now, the one that I'm going to implement is this guy here. So we have, so this is the architecture that I'm going to be using when all said and done. As I mentioned, there's some pieces that I'm still working through. So as we go through this series here, I'm going to, the end result is what you have here, which is the Power BI or reporting visualization to visualize our data. So this architecture here gets the data. You can either use it structured or unstructured, and then we're going to ingest that data using either shortcuts or pipelines, and then we'll store that data into our lakehouse. Then from our lakehouse perspective, we're going to go ahead and do data transformation, and the transformation process is where we Fabric engines can access and manipulate the same data set that's stored in one lake without duplicating it. So that's one of the key pieces there, that we don't duplicate the data. And then from storage perspective, is flexible enough that it's allowing us to use that medallion architecture, as well as do data mesh, which is where we can be able to bring other data points that we want to use within the environment. Any questions so far? All right. So if no questions, then I'm going to go ahead and proceed, and I am going to now switch over to my Power BI service.
Okay, yeah, I have a question.
Go for it.
What's the difference between one lake and data lake?
So the one lake, that's a very, very good question. And that's one of the pieces that I did not dwell on from introductory perspective. But one lake, let me actually see if I can bring, I have it here. That's that one right there. So one lake allows us to be able to, it's the one lake is the platform. So anything that we are putting on our Fabric, it's ensured that we end up with the same security model. So it's allowing us to remove the complexity of complexity of security, complexity of data duplication and such. But OneLake ensures that from our platform perspective, as you can see here, we have Fabric as one of the features here for the modern analytics and governance. So Fabric, then you have your Purview, then you have your Azure Databricks, you have the pieces that you guys have been dealing with, which is the cognitive services, OpenAI and ML. And then on this side, we are working on Azure and Cosmos DB. All these pieces here, they ensure they all lie within OneLake, which allows us that the permissions that I've applied to Fabric is the same permission or is the same security model that we apply to our OpenAI or our cognitive services. So OneLake, instead of having different data models or different pieces that make up the, from security perspective, make up this guy here where you're managing it individually, the OneLake is what allowing you to be able to do that. Now, that's now from a security perspective to ensure that the data is secure. Now, from Lakehouse perspective, Lakehouse is actually a data store. So that's actually where we are actually storing data. Does that make sense? Does that answer your question?
Yes, that makes sense. So just to confirm, it means that OneLake will enable that you don't have a duplicate of data storage. For example, the cloud database will access it from OneLake, the same platform without having a duplicate of OneLake, and the same to modern analytics and AI platform. They are just accessing what the security model is just one and applicable to all.
Correct. And if I do, I had promised that I'll show you guys something. So let me go here. Okay. So this is for my local machine here. So this here is my OneLake, and you can see here I have different folders that I can be able to actually. That's my workspace. This is my running resources. This is so. OneLake is like a single source where we can be able to all access the same data without having that data duplicated in different places. So think of it like a OneDrive of data.
I think I've understood it so well.
Yeah. So so this is where, and you can see here, like for instance, what I'm seeing here. If I go to, let's go back to the service. So I see, like, for instance, we have Eric's Lakehouse there, SOAP Data Lake there. So if I go back to my Power BI here, and I do see that. So this is Eric's, that's what we are seeing here. Eric Lakehouse. So I can see it's the same. So it's like OneDrive where I can actually be able to have shortcuts. So in this scenario, if I wanted to apply data for his piece here, I can be able to give him files. I can be able to drag files here. And once I drag those files, now they will be accessible from his Lakehouse. So it does allow us to give us that, also the shortcuts to the data. And then once you have that shortcut to the data, the security piece of it is also applied because the platform is all coming from the same place. Make sense?
Absolutely.
Okay. All right. So now jumping over to Power BI. So this is just my normal Power BI here. And I think pretty much everybody in the team should have Fabric. We haven't, so it's still going to be trial. Haven't seen the need yet for us to invest in the actual licensing. So if you're learning, you want to take advantage of that prior to it going kaboom, and then we decide what we want to do next. So from Power BI perspective, we have these features here. So these are some of the pieces that we're going to be covering over time. But I'm going to dwell on the data engineering, which is what we started with this morning. So from data engineering perspective, I have now, this is the same architecture that I was showing you guys earlier, where we have our Lakehouse, we have our notebooks, We have our Spark jobs, we have our data pipelines, and then we have we can be able to import notebooks and what have you here. So so now what we can do is, because I want to be able to ingest data here, I can come and create a lakehouse, and we can call this one Demo Tuesday. Sorry, for my case, I don't need to here. And it does not like us to have, actually, I don't even think the underscore. Yeah, we can do underscores. Also Demo Tuesday Lakehouse. So once we create that, now it gives us this ability here, and you can see now we have the structure to do tables and files. So these tables and files is actually the same piece that you did see on my on this one here. So on the workspace perspective. So as this data refreshes, I will be able to see Demo Tuesday here. Eventually it's going to sync, and then I can be able to drag and drop files directly here rather than having to actually even use the browser. So eventually I'm going to have that as a shortcut that I can be able to utilize, and not yet there. It's not there yet. All right, so then if I come back here, and I see that I have structures for the table, and those files that I do provide from the shortcut will show up here. Then, as you can see at the very top here, I have my Lakehouse, and I can be able to interchange this between Lakehouse and your SQL Analytics. So from SQL Analytics, this is where I can actually be able to write queries, and you can see this one here, as I mentioned during our call, that you have the ability to integrate both Lakehouse and data warehouse together. So this is where I can actually go ahead and add a data warehouse, but I'm not going to dwell on that in this one here until we get to the data warehouse side of it. So here I only want to deal with the Lakehouse side. And in the Lakehouse side, we have the ability to either upload data. We can also be able to pull data using the Gen 2, which is the pipelines. So these are different ways that I can be able to get data into my Lakehouse. If you don't have this shortcut here, you can still be able to use these ones here, which is the same thing as we do from Power BI today. So similar situation over here. Actually, I had not seen this one here, which is the event stream. I need to explore that a little bit more. And then we can be able to create new semantic model. So the semantic model is now, once you create the data, once you bring the data into your data set, now you can be able to build your relationships. You can be able to build the tables, how they relate to each other. That's where the semantic model is coming from. And then the notebook, these are the ones that we talked about, and we're going to be dwelling that more as we go through this series here. That does allow us to be able to do the coding from a notebook perspective rather than having it coming from, so notebooks, we talked about that. And then this one here, I haven't explored this one to see what it has. So that's another piece there that I'm not going to talk much about yet, because that's something that I haven't talked about or haven't explored. So in my scenario here, I'm actually going to get data using the Dataflow Gen 2 here by clicking on it. And then this will give me a scenario, and this could be the reason why my data didn't really work the way I expected it to work, but we'll see. So from data flow perspective, you can see there it does create me a data flow, and I can label that if I want. So this one here will be my Demo Tuesday. It's Demo Tuesday. And then from confidentiality perspective, we can set how we want this to be. So I'm just going to set that to our testing. And then, of course, it will tell you who the owner is and what workspace it actually belongs. So in this scenario, it's actually dumping this in my workspace. The next pieces here is getting data. So now we want to pull the data in, and as you can see, we can pull data from Excel, we can pull data from a SQL server, which will behave the same way Power BI does, where we can define the server, the database, and whatever type of connection that we want to use. But in mine here, I'm actually going to import data from a CSV. So I'm going to go ahead and do that. And then I can use a link. So this is also that concept of where we use data where it is. That's another strong selling feature of Fabric. I don't have to bring data into my environment. I can leave data where it is and still be able to use it. Or if I want, in this scenario, I'm going to go ahead and bring my data here. And I'm going to go back to my folders here. I'm just going to drag a CSV that I do have. Okay, so once I do that CSV, this is the connection that it has created for my data here. And if I wanted, I can edit it. So again, we are able to set what we want there, the privacy level. We're going to set that to organization, and we know who the user is. You can switch the user if need be. And if I was using data that's coming from an on-prem perspective, then I would have a gateway and the on-prem. So this, think of it like, for instance, if the data sits in somebody's computer, they have the ability to bring that data in. And for them to be able to do that, we have to have a tunnel or a secure process that connects between the cloud and your on-prem environment. That's where the gateway comes into picture. So we have that. So then I'm going to go to next here. It's creating my data source. So this is the type of data that I do have out there, which is just a CSV file that I am looking at the data. So I have these pieces here. I can go ahead and add other templates, other tables if I want. But in this scenario here, I'm just going to go ahead and create. So once I create this data, so you will notice two things here. So that's my data there. As I want it. If I wanted to do transformation, I can be able, just like the way you do today with Power BI, we can be able to do that transformation where I can remove this row if I wanted to. I can transpose the data. I can do whatever I want to with the data here, replace the data set and such kind of things. So we have the ability to do that, be able to create additional columns if we want to do calculation. And this is where that M language comes into picture. So if I do a custom column here, I can be able to, let's say, for instance, combine customer and let's say category. So this is that M language. So this is Dev Tuesday. And these are things that you can do today within Power BI. And unexpected token, need to do that, I believe. And that's just concatenating between those two. So I end up with Dev Tuesday here that will have the customer, and you can see the concatenation between that, which is the customer, and whatever that the category was here. So that and that one, that's what I did there, just that concatenation there. So I have the ability to do the data manipulation here, as I can do today within Power BI. Be able to view if I wanted to do the scripts or that. So these are still things that you do with Power BI, Power Query today that you can always be able to do. I want us to focus at the very bottom here. So you'll notice where my destination is going. So this defines where this data, once I publish it, is going to go. So it's going to go to the workspace, and then it's going to be loaded into my lakehouse. And once it gets loaded into my lakehouse, then I have the ability now to go ahead and use it. At that point now, I've ingested my data and it's in my lakehouse, so I can start doing my other transformations that I want to do. So I can also be able to publish as a user, or I'll publish later, or publish now, depending on what you want to do. So I'm just going to go ahead and publish this. Come on. And over here, so that took us back to, let's go back to this workspace here. So we should have a new data lake here, which is that. And our data ingestion should end up here. as soon as it's done. Let's see where it is. So that's my semantic model. And in my semantic model, before we do the semantic model, I should also see my pipeline here, which will be called Demo Tuesday, which is that one. So it created this pipeline here. And as you can see, that pipeline is still in process. So you can see that it's actually now ingesting the data. And we can go into it. Not yet. Okay, I'll go to one that already exists. Let me see if there's one with the data. I think I have data in this one for the sake of time. I do not. Yeah. And to exit that, I have to actually tell it that I want to close. Otherwise, it's going to give you that scenario of you have unsaved data situation. Let's see where we are. I've got a bit going on here. Yeah, so this is the issue that I was mentioning at the beginning of call that I'm trying to figure out why. So it did fail. So it did not fully ingest my data here, which is data missing credentials invalid. And that there should be, let's go back here. I did this guy. That's not what I was dealing with last night. Yeah, so that's fine. Still it. Don't care about that general. And let's look at my source here. So when I use that property there for uploading the file, that file is actually going to end up in OneDrive. So that's also a key piece there to note that this file does get stored in your OneDrive. And in my OneDrive, I have I'm not certain yet where it's storing it. I'm not certain yet where it is in my OneDrive, but that's where that data is ending up on the OneDrive there. We can put that if we wanted to. What I'm looking for is why it thinks the permissions are not right. So we have that, and we have that's personal cloud. Let me go ahead and change that. I'm going to change that to none. And authentication, I'm going to change that to basic. And let's use that. Okay. So we have that, and similar situation here. That's the one that we just updated. Okay, so we have that, and let's go ahead and try to do a refresh. And I'm going to publish it one more time. So we'll see if it's going to work this time. But yes, so because of time, so that's actually the process that I'll be building on here. So now once we get the data into, going back to the architecture that I showed earlier, let me go back to my PowerPoint here. Based on the architecture that I have here. So based on this architecture here, so this is the piece that I am working on now, which is the ingestion process. And then once I finish this, then I'm also going to bring in unstructured data so that now we can enrich this data here with the goal of us now having that medallion architecture that we talked about. And then that data now, once it ends up, once we have the unstructured and the structured data, which is the structured is what I just brought there, then now we'll start building on the transformation. And we did a little bit of those transformations, but we will start working on the notebooks and such so that now that can be enhanced there. And then eventually we will get to the consumption, which is going to be Power BI. So with that, I am at the end of my time.